Alarm 51. Motor over temp. We're going to have to look at the circuit that's monitoring that motor thermal. Here's the control board out of that Indramat Servo drive that's tripping on alarm 51. Now right here, these two top pins right here, this is TM plus and TM minus, that's where the motor thermal connects. So we're going to follow it in and hopefully find out why that alarm is triggering. I could see by examining the board that somebody else has been working on it. I've got scratch marks right here and right here between this capacitor and this choke. I'm going to follow pin 1 first. Let me get my close-up glasses on. Follow pin 1 and see where it goes to. There's a trace coming from pin 1 going right here. That heads up here to where the scratch marks are. Get my hat off here so it don't get in the way of the camera. I'll put my meter in beep mode. Okay, yes, it does go there underneath this rail right here. But where does it go from there? It looks like it runs over here underneath this capacitor. I'm going to have to remove that capacitor to see where the trace goes. Go ahead and get that out of the way there. Yeah, maybe we can see where that trace goes to. So we need this glue right here that was holding the capacitor in. Let's see if I can find it on the other side there. Come on, beep for me. Somebody beep over here. I know you go here someplace. Come on. Maybe that's why it's not working. A few more parts off the board. See if I can get this capacitor off of here. Add a little bit of solder. Come on. There you go. That's it. That's the trace. We have continuity from there to this via underneath that inductor right there. Comes over here. I'm going to have to get this removed somehow. side. Isn't this strange? Somebody's added a capacitor right there. There's a diode that looks like it's smoked. Found the problem. Diode right there. There's a diode right there that looks like it's been opened up. You see by the way it's darkened like that. Alright, I'm going to have to figure out what that diode is. I'll go see if I can find another board in the back that looks like this one. I'm back in a little bit. Here's the circuit off of a control board off a blown up drive. It's not a diode. It's a resistor. Let's measure its value. It's 200 ohms. Let's go ahead and measure this one over here. That's 10K. So I thought it was a diode, but it's not. It's a resistor. And it's opened up. You can see it's smoked. I'm going to go ahead and replace that. And we'll see what happens. I'm going to install a 1 watt 200 ohm resistor in place of that surface mount resistor. Let's figure out how I can get it in here. See if we can bend the leads like that. I've been comparing this circuit right here that was damaged to the control board that came out of the destroyed drive that we had in the back. And this diode here that was connected to that smoked 200 ohm resistor, it doesn't measure the same as the one on the other control board. So here we have 1.408K. I'm in ohms mode, and that was forward biasing the diode. And here, reverse biasing the diode, I have 1.243 kilo ohms. I'm going to bring the other board over. Set this one over here, and I'll show you the confusion that I'm having with that diode. Now here's the control board from the blown up drive, and there, look at that, that's 1.712 mega ohms, not kilo ohms, mega ohms. That's forward biasing that diode. I'm going to reverse bias it, and look at that. That's a good diode right there. I think that diode over there is also bad in that motor thermal circuit. I'm going to take the diode off of this one and swap it out with that diode over there, and we'll see what we get. We'll see if that fixes that difference between the kilo ohms and the mega ohms. This board right here, this board's no good, so it's not going to hurt me to take parts off of it. Okay, come on. I wonder if they got it glued to the board. It looks like it. Don't want to break that diode. Get some magic solder. Remove that diode with the magic solder. Now this is the good diode that I'm removing. There we go. We got it off with the magic solder. Set that right there. Let's move that bad control board over there. Okay. Let's move this capacitor out of the way here. Get that capacitor removed. Let's see if I can get that. There, that one come right off. Now I'll clean up the pad with the solder wick. Let's take this good diode. I want to remove the magic solder from the good diode. There we go. That should do it right there. I'm going to test this diode and make sure it's still good. Let's go into diode mode this time. Okay, we got a diode voltage drop of 0.631. That's good. That's forward bias. Let's reverse bias. And it's open. That's good. Set that over there. Let's check that diode that we think is bad. It's forward biased. Get on there. Yeah, it's moving around on me. I don't have a flat spot to get onto. Yeah, look at that. Come on, hold still. There's 0.738. Reverse the leads. There's 0.417. That diode was damaged. I thought it was okay in the circuit, but it was damaged. We have a leaky diode in that circuit. It's a good thing we looked at that. Let's install the new diode. Okay, I'm going to add a little solder right there for an anchor point. We don't want to put that in backwards. Make sure we get the cathode and anode going the right way. The cathode is the black band and the anode is the other side, the unbanded side. Need to add a little bit more solder. Put enough on there. Let me go to a thicker solder. Get on there. Hard to solder this tiny stuff. Just don't want to sit still. Alright, move that capacitor back over there so we can get it soldered back in. Reflow this side. There we go. There we go. Let's check that diode in circuit. Okay, there's a diode voltage drop of 0.627. Let's reverse. That was forward bias. Let's reverse the leads. Look at that. I think we got a good circuit now. Reversing the leads. We opened up that depletion region of the diode and we had no voltage diode drop. That one's not leaky. Right here is that operational amplifier that I'm going to replace in that motor thermal circuit. I'm going to use this Chip Quik right here to help me get that IC off the board. Let's apply some flux. I'm going down into the canyon here. I don't want to melt none of these capacitors or relays, so I got to be careful. Just spread that Chip Quik across the pins. Keep applying heat until the IC loosens up from the board, just like that. Now I have to get the Chip Quik removed from the board. So I'm going to use this solder wick, apply some flux to the solder wick. That will help the Chip Quik flow up into the braid. You have to get all of that Chip Quik off the pads. You don't want to leave any behind. Go. Now, I'm going to use this denatured alcohol and a swab to remove that flux. Try to get all that flux out of there. It just makes for a more professional job if your board is clean. Okay, let that alcohol dry a little bit. There we go. Now we're ready to put the new IC on. Got the IC set, and then I've flowed solder on that side. Now we're going to get the other side. Couple more pins. There we go. So we had a smoked resistor, a 200 ohm resistor, a leaky diode, and just for the sake completeness, we changed out the TL084 AC. So I think I'll clean up this board now. I feel real good about it now. We can put this back together, and I think we've fixed that alarm 51 problem. We'll see. Give me a little bit to get this board cleaned up and that drive put back together. We'll hook it up and see what it does. That's all back together minus the cover. I'm going to hook it up. Now, I'm not going to show you the hookups here. I'll provide a link to another video where I repaired an Indramat Servo drive and I show you the hookup. So I'll provide a link to that video. Alright, I'll be back in a little bit. See you shortly. Alright, I got the drive back together and hooked up to run a motor. Let's power it up and see if we trip on alarm 51. I'm applying 220 volts AC to the bus power supply. Alright, we fixed it. We come up to AB. Alright, good job, people. Good job. I'll move the camera back and we'll see if we can run a motor. Let me power it down first. That is good. That is good. Let's apply 220 volts AC 3-phase to the bus power supply. Good. Came up good again. I'm going to close the RF to plus 24. Just went to RH on the display. I'm going to close AH terminal to plus 24. There we're moving. That's a little bit noisy, but that's because this isn't the motor that mates to this servo drive. That motor's in the machine at the factory. I don't have it. Let's go the other way. There we go, folks. We repaired that drive of alarm 51.